Okay, just a couple more. Here again we have a square root, so we're probably going to need to check our solutions. So first of all, let's use our reverse BEDMAS. So if I had a value for x, say like 14, and I wanted to try that to see if this worked out, I would take that 14 and I would add 2 to it. So the first thing I do is add 2, then it becomes 16, then the next thing I do is take the square root, then it becomes 4, and the last thing I do is subtract 3. 4 minus 3 is 1, 1 is not equal to minus 5, so that was a bad guess. I don't suggest solving this equation here by guessing and checking, although if you actually see something that might work, then that's always a good thing to do. Okay, so let's instead use an algebraic procedure. So remember, the first thing I did was add, then square root, and then subtract. So I'm going to reverse that. So the first thing I need to take care of is the subtraction. I do that by adding 3 to both sides. Completely reversible process by subtracting 3. So we add 3 minus 2, this term goes away, and I get the square root of x plus 2 is equal to minus 2. Okay, now I've got to square both sides. Let's write that here. So we can put in our little arrows to show that if these are equal, then these will be equal, but this doesn't go back that way, so that means we're going to have to check. So x plus 2 equals 4. Now we can go and subtract 2 from both sides, which is reversible, and then that gets me x equals 2. Okay, so that is one possibility. However, because of this stage right here where I squared both sides of the equation, I have to go back and make sure this works prior to squaring. And when I do that, I get the square root of 2 plus 2 minus 3 is equal to minus 5. The square root of 4 minus 3 is equal to minus 5, which means 2 minus 3 equals minus 5. And that is clearly not true, and you can see that the problem is the sign right here on the thing that we squared. So if that were a minus, this would work, but it does not. So this equation right here has no solution. No solution. Okay. This one here is slightly different. What we've got going on here, well, you'll see what we've got going on here. So 2 square roots. So the very first thing we need to do is square both sides. And that's going to lead us to the fact that this step is not reversible, so I'm going to have to check my solutions. So x minus 4 equals 2x. And let's see, let's move this x to the other side. So I'm going to subtract an x from both sides. Minus 4 equals x. That's a reversible process. Adding or subtracting an x from both sides can go either way. And then here is my solution, which I'm going to need to check. So I bring it back and I get the square root of x is minus 4, so minus 4 is equal to the square root of 2 times minus 4. Square root of minus 8 is equal to the square root of minus 8. Okay, now this is 100% true if you are working in imaginary numbers or in the even larger group of complex numbers. So in both of these cases, negative 8 does have a square root, but in the real numbers, anytime we square something, if it's positive, it becomes positive. And if it's negative, it also becomes positive. So there is no square root for negative numbers in the real number system, which means that this doesn't make any sense if we're operating in the real number system, which is what we usually are. So there is no real number solution for this. Even though the minus 4 is a real number, it creates a negative inside our square root, and we don't know what that means if we don't have imaginary or complex numbers. Okay, finally, this one right here is quite similar in some ways to the one we just did. There's no square roots, but how are we going to solve something like this? Well, whenever I have an equation that has fractions in it, I like to get a common denominator for all the fractions, and then I just go ahead and multiply by that common denominator. So I'm going to multiply both sides of this equation by x minus 10. Now, usually multiplying by something is completely reversible. There's only one instance in which multiplying by a number cannot be reversed, and that is when the number is 0. So when we're multiplying by a variable, we don't really know what this number is. We have to make sure that it is not 0, which means in this case that x cannot be 10. But you'll see here when we go ahead and move to the next step and cancel this out, that our solution requires that x be 10, but x is not allowed to be 10, so there's no solution. And here's what it actually looks like. If you go back and put that 10 in, we're going to put it in here, we get 10, we put it in the denominator, we get 0. Here, again, 10, and putting in 10 in the bottom gets a 0. And this might look like these are equal, but it's kind of the same as here with the square root of -8. And in fact, it's even worse because there is no number system in mathematics that can explain what this is. This is complete nonsense. So it's not defined, so we can't say two undefined things are equal.